Let's keep working on practice questions. This next one is y plus 3 over y plus 2 minus y over y squared minus 4 equals y over y minus 2. We need to factor anything that isn't fully factored yet. So I have a y plus 2 times a y minus 2. And I need to check for any restrictions on my domain. Y cannot equal negative 2. Y cannot equal positive 2. Now let's look at the LCD. The least common denominator is going to be y plus 2 times y minus 2. That's what I'll multiply both sides of my equation by. When I multiply the first fraction by y plus 2 times y minus 2, my y plus 2 will divide out, and I'll have y minus 2 as a factor left in the numerator. Looking at the next fraction, I have minus y times the y plus 2 and the y minus 2 will both divide out, and I'll just have negative y times 1, or just negative y. I'll then have an equal sign, and I'll multiply my LCD to the y over y minus 2. My y minus 2 will divide out, and I'll be left with y times y plus 2. Now I'm going to FOIL the first set. That will give me a y squared plus y minus 6 minus y equals y squared plus 2y. Since I have a y squared on both sides, I can subtract those. And those both add to 0. If I have a plus y and a minus y here on the left side, those add together and just equal 0. So I'm left with negative 6 is equal to 2y. Now I can divide both sides by 2. And y is equal to negative 3. Since negative 3 was not one of my restrictions on the domain, I can say that y equals negative 3 is the solution to that rational equation. This last equation is 3 minus 2x over x plus 1 minus 10 over x squared minus 1 equals 2x plus 3 over 1 minus x. Let's go ahead and change this denominator so the x comes first. That will give me a negative x plus 1, and now I'm going to factor a negative 1 out. That will give me an x minus 1. Now if I were to bring that negative 1 out front and think of it as 2x plus 3 divided by negative 1 times 1 over x minus 1, this would change the signs of the numerator. So I can distribute that negative through to both terms in the numerator and leave the denominator as an x minus 1. This is what I'm going to do in the next step. I'm also going to factor this x squared minus 1 to an x plus 1 and an x minus 1. So let's rewrite the whole thing. 3 minus 2x all over x plus 1 minus 10 over x plus 1 times x minus 1 equals negative 2x minus 3 all over x minus 1. Now we're going to see what the restrictions are on the domain. X cannot equal negative 1, and x cannot equal positive 1. Those are our two restrictions. Now we need to multiply both sides of our equation by the LCD. Now the LCD, least common denominator, is going to be x plus 1 times x minus 1. Multiplying through by x plus 1 times x minus 1 on both sides. In each term, at least one factor will divide out. We'll have 3 minus 2x times x minus 1, because the x plus 1 divided out. Minus 10 times x plus 1 and x minus 1 both divide out, and you'd be left with a 1 here, but we don't even have to write that. It's just minus 10. Equals negative 2x minus 3 times the x minus 1's divide out, and we're left with an x plus 1 as our multiplication. Multiply those binomials together. I'll have a 3x minus 3 minus 2x squared plus 2x minus 10 equals negative 2x squared minus 2x minus 3x minus 3. I'm going to look for any terms that are identical on both sides of the equation, so I can just cancel them out. So I have a negative 2x on both sides. I can get rid of that. I have a, doesn't look like there, oh, I have a negative 3x, just a negative 3 on both sides that I can cancel out. So then I have the 3x and the 2x that I can add together, so that's 5x minus 10 is equal to negative 5x. And then I'm going to subtract 5x from both sides. This will give me negative 10 is equal to negative 10x. If we divide by negative 10 on both sides, x equals 1. Now, one of our restrictions was that x cannot equal 1. So we have no solution once again. So this won't happen all the time, but it's really important to remember to list the restrictions on the domain before you solve your rational equation, or you will likely find a solution that actually doesn't exist given the restrictions.